Hello everyone, and welcome back to another video that's going to focus on global weather events that are not being reported in the media and a different way of looking at what might be happening to the poles of the Earth. Before I cover the three topics I wanted to cover in this video, I wanted to just point out as a reminder that I started this sort of series or this effort by creating a video covering the hurricane-like low-pressure zone that pushed up into the North Atlantic and over the North Pole. In that video, I also introduced the idea of the fault lines, the Mid-Atlantic Rift specifically, that pushes up past the North Pole, and the active volcanic zones that are located in that rift in the North Pole. In a second video, I actually introduced the idea that it may be possible, and I shared some data to show why I believe it's likely that this rift is the reason the North Pole is melting so much. And then I also want to make you aware of, if you haven't seen it, I created a video very carefully that covers CO2 and the global warming topic. I did this in a very respectful way. I'm not trying to rub anything into anybody's face, and my hope is that this is just information we can all use. So if you haven't seen that video, I recommend that you check it out. If you disagree or see something that I said wrong, I'd love to see your feedback in the comments. I'm very open to the idea that I might have misstated something. But I think it's information that has not been shared in the mainstream media or in the media in general. But this perspective is one that could have a significant impact on what you believe about what's causing our Earth to warm up. Okay, global warming is real. The question is that I'm trying to answer with that video is CO2 the primary driver of that? And I do it in a very high level sort of way. Anyway, enough on that. Let's talk about what's going on today or this week with the North Pole. And I'm going to also touch on the South Pole as well, just to give some context there. The biggest news is this earthquake. And if you look, this is an earthquake tracker piece of software called Earthquake 3D. It's a free download, and I encourage you to check that out if you have an interest in this sort of thing. But this is Greenland and Iceland for context. Over here is a 5.0 earthquake that is right off the North Pole. In fact, if I turn off the rings, you can get a really good precise location of that earthquake, right? So there's your North Pole, and that's where the earthquake happened. If we minimize this tool, then you can see again exactly what's there. There's that Mid-Atlantic Rift coming up to the end, and at the end, by the way, I've mentioned this before, is a supervolcano. At least many people believe that's what this is. It looks exactly like the caldera of a supervolcano, or the pit that's formed for a supervolcano. This is slightly larger than the Yellowstone National Park here in the U.S. supervolcano, or the supervolcano in Italy as well. But it has a very strikingly familiar shape as well as general look and dimensions as well. So there's the volcano. That earthquake would have hit somewhere right about in here. North Pole would be right over in this area. So we're talking about less than 100 miles, maybe 100 miles from a supervolcano. Now ask yourself, if there was a 5.0 earthquake within 100 to 200 miles of Yellowstone National Park and that supervolcano, or close to Italy, would that have made the news? It certainly would have, and we would have had geologists up there trying to figure out what's going on. And we've seen no activity, no news coverage, and I just think that's strange, so I wanted to bring it to your attention. This is a really significant event that lends a lot of credence again to the fact that this is a very active fault line, or a part of a very long fault line that is putting a lot of heat into the water right under the North Pole. Now when we talk about heat, we're going to go back to another area, but I'm going to show it to you in a different way. Okay, so this is the same application or the same website. If you look up here, earth.nullschool.net, you can check it out for yourself. It's a very cool site that shows atmospheric as well as ocean surface temperatures and currents and things like that. But here, what I'm looking at is what's called the SSTA, and I'll There you go, the sea surface temperature anomaly. So it shows over the past 15 to 20 years, the average temperature of every area around the Earth based on satellite data and modeling and so forth. And then it takes in new data and shows where there are anomalies. Is it higher than average or lower? If it's warmer, you see it show up in the spectrum in the red to yellow to white side. If it's colder, you see it in the blue spectrum, going from deep purple all the way through white again on the low side. So when we look at this imaging, and again, Greenland, Iceland, and over here is Sweden and so forth. But just up here, again, I've spent a fair amount of time talking about this little Russian group of islands. And if I zoom in, look at the anomaly. All right. I also want to flip over and show you a picture. All right. So here is the average ice sheet location with it represented by the orange line, and then you can see how far it's set back. Okay, so it's definitely receded, and it's a little bit over here on the Alaska side and Russia side as well. But in the news, this is the biggest and most significant melting and reducing of the ice sheet. So I wanted to show that to you. And then again, if we come back, well, let me point this out. There's these little Russian islands I like to use as a reference point as well. And the melting comes up into that area a bit. But it hasn't receded a whole lot, right? I'm going to show you why. And then up here is where the recession has really happened in the ice sheet. And I'll show you why there as well. All right, so here they are. Big hot spot. If we look at the temperature, 14 degrees Fahrenheit. This is 14 degrees above normal temperature, okay? And I've been seeing this and tracking this as high as 20 degrees over. In fact, this one, look at that, 17.3. I want to see if I can find just this morning. Yeah, it's right over here. It was 20 degrees above normal for the past 15-year average, okay? These are definitely hot spots. They are pushing hot water via thermal vents up into the ocean, and they're melting it. If you look at the current direction, I can zoom in a little bit here, you can see that off of this hot spot, everything is pushing south, which explains why the ice sheet comes right up here just north of this underwater thermal event, okay? This side, however, huge thermal event, a smaller one here. This one used to be yellow a couple days ago, and it just seems to be cooling down right now. All of this water, and these water currents is what we're showing here, are pushing north and up. And this is why this entire region has melted in the ice sheet more than normal. Again, just trying to make the case, it is not necessarily contributable to CO2 heating the air, and I tend to believe that the ice sheet is melting from underneath, so I wanted to point that out. Now, I don't want to go too long with this video, so I'm going to quickly, I guess I should just, for reference, to show you, I think it's kind of really interesting, if we go to ocean sea surface temperature, things are going to look a little different, but if I click in here now, look at this. It's 50 degrees Fahrenheit. And just for our folks that aren't in the U.S. and don't use Fahrenheit, 9.9 degrees Celsius. Okay. This one over here, 53. This is water temperature. Okay. Ocean water temperature at the surface. It's 53 degrees. There's no ice here, and this warm water is pushing right up. Just wanted to show that. All right, let's go back over. Whoops. To the anomaly and tracking, and then we're going to pull back, and I'm going to really quickly switch down to the South Pole on this map. Okay, so here's South America, just for reference and context. Here's Africa coming down. Over here is Australia. Okay, now I want to show you a couple things. Okay, so the first thing I want to show you is an article. Kind of an interesting article, and this is from September of 2016. It's on the climatechangedispatch.com website. But volcanic activity supplies natural mercury to Antarctic glaciers, not humans. And the article itself is very interesting. Just for instance, I'm not going to read the whole thing. Numerous media articles are claiming that the discovery of mercury and associated methylmercury in West Antarctic glaciers is a major man-made environmental disaster. However, these claims are incorrect because this mercury is actually from local volcanic sources. Okay, research studies prove that mercury is common and naturally generated and then naturally altered to methyl mercury in volcanic environments. Okay, so everybody panicked and said it must be human disaster occurring when methyl mercury was found in Antarctica. And the truth is, and you can see here, I think this is a great graphic. In fact, I've blown it up here to make it a little larger. This is the fault lines in Antarctica, for East Antarctica at least. And so you can see it curls around and then comes in, and that's what this peninsula is. Actually, two fault lines dividing. One goes down the coast, one creates the mountains across Antarctica. All right. The red dots represent volcanoes. Look at all the volcanic activity. Okay, so when we talk about melting ice sheets, melting glaciers in West Antarctica, what we're talking about is potentially volcanic activity again, heating this up. Also, you notice the fault lines are off the coast in much of this area. So if they're off the coast, those volcanoes are underwater. What we've learned is that along all of these, in fact, I can show you a video that I recommend, and I'll post in the comments section below. Scientists have discovered that there is enormous life and activity in the hydrothermic vents under the ice shelf in Antarctica. I'll post a link to this video. I think it's a very good one. They don't talk a lot about what this means. They just talk about the fact that these hydrothermal vents exist. Okay, but there's no doubt they're melting ice. The point I want to make here, again, is going to drive back to that CO2 is warming our planet and so forth. And the way they explain the melting ice is that there's no denying it that Antarctica is melting from below, but they're explaining it as saying that CO2 is warming the atmosphere, is warming the ocean, and the ocean currents are pushing warm air under the ice sheets. Well, look at this map here. These are the anomalies again. So no doubt there's a lot of warmer than average water all around the globe. But the blue areas are colder than average, and there's no current showing that it's pushing up. In fact, all around the coast is sort of a band of cooler than average temperatures. Okay? Specifically, let's zoom in a bit. You might have heard in the news about the Larsen B ice shelf. That's this gray area here just off the coast in this peninsula. Huge ice sheet, permanent ice sheet, and a crack has formed that's over 100 miles long. It's going to create potentially the largest glacier we've ever seen, right? So if that happens, that'll be interesting, but look at the anomaly. And if I click down here, you can see it ranges. And right now it looks like 1 degree right about here. Okay, so 1.5 to 2 degrees. And you notice it gets warmer as I get closer to the ice sheet. So what I'm theorizing, what it appears based on the data to be true, is that under the ice sheet is a thermal vent that is heating. It's along the fault line, which is under the ice sheet, right? So it's coming along here, and there's a thermal vent that's heating the water and it's creating this anomaly compared to the 15-year average warmer water, and that warmer water is melting and cracking the ice sheet off. Okay, it just makes sense, right? We've shown there's a fault line here, fault lines, and I've even shown you a video explaining the incredible life on top of these fault lines because of the incredibly hot water bubbling up from Earth. That heat is melting the ice. Okay, the other one that you see a lot in Antarctica news is everything's backwards here. Is right over here. There's the largest glacier in Antarctica is right here. I think I might have a picture. Okay, it's called the Totten Glacier. It's very big, and this is in East Antarctica over here. So right down this red area is where the primary issues are happening, and that's the melting. And there's a lot of curiosity, and the scientists say that if this ice sheet melts, it could set off kind of a chain reaction that starts to melt the actual glacier at an alarming rate. Okay, all that could be true. However, again, right off the coast, you see the anomaly, warm water. Okay, so this warm water, there's fracturing here. It's a different kind of a fault. but there is definitely hydrothermic activity happening here. And again, the question we need to answer is, why is this hydrothermic activity increasing? Why is volcanic activity increasing? I might create a video on this specifically because there is a lot of volcanic activity around the world, and there's a lot of fireballs, near-Earth objects, and comets being discovered all around Earth as well. I think that something is affecting our planet, and that effect is causing the tectonic plates to shift a bit and causing the earthquakes, the volcanoes, and the hydrothermic vents to chime in. It's heating the water, it's heating our air, and naturally all of these events release CO2 in the atmosphere as well. So that's really what I wanted to show you for this video. I hope you found this interesting. If you have any questions or comments, I really do read and look forward to your feedback in the comments section below. I will attach links to the videos and the article that I shared here as well. Have a great day.